Hello, welcome back to Cracking the Cryptic, and an intriguing looking puzzle today. A sandwich and killer mix by Redundant, who we've seen on the channel a few times, maybe a couple of times before. Excellent constructor, so I'm looking forward to this. Now, today when this comes out, there are, how many hours? I'm just trying to count the hours, 17 hours left to enter our 3 times a Sudoku competition on Patreon. Also on Patreon, Simon's Solve of Fistamafel, the April Fool puzzle, loads going on the channel, our apps. There should be an update to the Arrow app coming fairly soon, which is good news if you've been waiting for that. And you can check out all the links under the video to find our catalogue, our apps, SUDOKU PAD, the credits for the music and so on. So it's all there. And the first link is to this puzzle called Plaid Lunchbox by Redundant. Not going to know why that is so called, I don't think. Now, the rules are these. Normal Sudoku rules apply. Digits can't repeat in a cage, and sum to the clue in the upper left corner. So these 3 digits add up to 11 and cannot have any repeat digits in. A clue outside the grid, so let's take this 9, indicates the sum of the digits between the 1 and the 9 in that row or column. So for instance, there might be a 1 here and a 9 here, and these 2 digits would add up to 9. They could be a 4 and a 5, for instance, and that would fulfill the 9 clue. Mouse is behaving oddly, slightly borrowed mouse. Anyway, those are the rules. That's all there is. So those are typical sandwich and killer rules. Those are 2 of our apps, Sandwich Sudoku and Killer Sudoku. But this puzzle's by Redundant, as I say, and I am going to start it now. Let's get cracking. Well, one thing, I'll tell you what I'm not going to focus on is this ring. Now, I have a feeling Simon would look at that and go, this could be a Fistamafel ring puzzle, because all but 4 cells of that ring are in cages, and you could add the sum of those cages and then compare to these cages, which will contain exactly the same digits as that ring that I highlighted by Fistamafel's remarkable theorem. And we know all but 4 cells of those, but I don't think that's going to be relevant. There, I said it. What I think is relevant is a 35 clue in a sandwich Sudoku. Now, the secret that we occasionally let people in on is that every row, column, and box in a Sudoku adds up to 45, which is the total of 1 to 9. Now, the sandwich secret is that the biggest possible sandwich clue is 35, and that is because if you were to put 1 and 9 in the edges, everything else would be 2 to 8. And if you subtract the total of 1 and 9, which is 10, from that 45 total, you get 35. That's the total of 2 to 8. So we know that here we have 1 and 9 in the corners. I'm going to colour them red, and everything else that can't be 1 or 9 green, because that actually sometimes helps. So in this column, there's a 5 clue. So the other end, the other crust of this sandwich is in one of those 2 cells. If it's there, that's a 2-3 pair. If it's there, that's a 5. There is no way, given the clue, by the way, that this can be a 9, that this can be a 1, because this clue would then, this cage would then need to contain a 9 and an 8. In fact, the 9 would have to be here, because that would be a 9. And then the clue for this column would be 0. So that's not a 1, that's a 9. Just because of the 18. So here's a simpler way of seeing that. I couldn't have put a 9 in a 9 cage there. That was more straightforward, but I didn't spot it. Right, in this column, at least 2 cells are in the 12 sum, but it could be 3. So the 9 is in one of those 2 cells. And this is a 23 cage. So we know it contains 9, 8, or 6. But the 9 must be in one of these 2 cells. So that one's green and contains 6 or 8. This is either 2, 3 or 5, because it's either 5 if that's a 1 or part of a 2, 3 sum if that is. So this is going to be 4, 6 or 7 to make up the total. The 11 cage doesn't have a 1 in it. So it definitely has a 2, and it's either 2, 4, 5 or 2, 3, 6. Which doesn't get enough done. Hang on. We've got this 23 clue at the top, and now the perimeters can't be crusts. So how many cells are in this sandwich? 23 is more than 8 plus 7 plus 6, which make 21. So it needs to be at least 4 cells big. Now that could be those 4, or those 5. But either way around, these 3 cells are, oh, that's very pretty, are not 1s or 9s. And if there's no 1 in a 3-cell 10 sum, then there's only one way to make it up. 2, 3, 5. And that's part of the sandwich. So you can't just have one more cell being 13. In fact, you must have 2 more cells in the sandwich. They're green. These are red. We probably know what the greens are. They add up to 13, and you can't use 5, 8 because 5's been used in the row. So they're 6, 7. The outies in this row, as we would call these, are 4 and 8. Now, can we use the cage totals? 186, 942. Those seem to be the 2 possibilities there. Here it's either, again, high-low, so 1, 8, what would it be, 7 or 9, 4, 3. I've got a 6, 8, 9 triple looking at that cell. There we go. That's how to do it. So 4, 9, 3 we said. This is now 8. That's 1. This is 6. They're all done. We're getting real numbers in the grid. That 6 sees this cell. So 7 and 6 are resolved. We've got 2, 5 and 7 to put in the column. This one can't be a 7, or that would have to be another 1 there. So this is now either 3 or 6. Oh, and that's very pretty. That means this can't be a 2, 3, 6 cage. Have I got the maths right? Yeah, I think I have. So that is now a 2, 4, 5 cage for definite. And this can't be 4. So that can't be 5. And now it's 2 or 3. That's really beautiful the way that's worked around the grid. The whole perimeter, we've been colouring the perimeter, and we've got to the point of knowing that that's not a single cell 5 in the sandwich. It's a pair of 2 and 3 in the sandwich, and we can place the 1. These 2 add up to 12 there, 5, 7. We get a 4 there. I wonder if there's some way of resolving this business now. 2, 4, 5, 9, 1. So these others are from 3, 6, 7 and 8 in the row. Maybe not. We're going to have to use some of the interior sandwich clues next, I imagine. 6, 0, they're not that useful at the moment. Maybe this, 26, right. We could from the beginning have put a green cell there, because if that was a crust, you just couldn't get to a perimeter and pack enough sandwich ins. But now we've got greens at top and bottom. I'm sure we can green all those out. Let's just think about this from scratch. The length of the sandwich clue, actually it's much like row 1. The length of the sandwich is at least 4 cells. 8, 7, 6, 5 is in fact 26. So again, whether it's those 4 or those 4 or all 5, the middle 3 are all covered. So they're in the sandwich. Can this be a crust? That would need 8, 7, 6 to make 21 and another crust here. Oh, it could be. Now, there are 4 cells in the sandwich, at least, and it could easily be 5. Now, if it was 5, the outies would have to add up to 35 minus 26, which equals 9. They would be a 5 at the top and a 4 at the bottom. That is possible. On the other hand, if this sandwich length is 4, That is an 8, 7, 6 and 5, and you don't have a 5 in the crust, in the perimeter. So I'm not quite sure yet what's going on there. Let's try and find something else to do. This 21 clue. Right, again, this has to have at least 3 cells in the sandwich. So that is in the sandwich. It can't be those 3 cells only, because that would put 2 digits from 6, 7 and 8 in the 11 cage. Therefore, the sandwich must extend to this cell. Let me just explain that. The only way to actually use a 21 clue as a 3-cell sandwich and for it to be those 3 cells, so this could be red, would be for them to be 6, 7 and 8, but that would break the 11 cage. So it's not just those 3 cells, so this is in the sandwich too. And now we know in this 26 column that one of the crusts has to be there. That is a 1 or a 9. Now it could still be 8, 7, 6, 5 and the other one here. What about the 21? Could it be those 3? Yes, I think it could. That could be 8 and 7 with 4 there, or 8 and 6 with a 5 there. So this can still be 1 or 9. Yeah, the foot sandwich could be 4 cells as well. I'm not sure if it can be 5. 2, 3, 4, 5, 7. It can't be that, so it's not a 5-cell sandwich, it's 3 or 4 in this row. But one of these 2 is now red. And there's only 2 reds per box, so those 2 are green. Don't think that helps a lot. One of these 2's a 4. Bit of ordinary Sudoku. One of these 2's a 1 by ordinary Sudoku. Right, that's in the 9. That's a crust for the 9 sandwich. So now the 9, could it be that far away? If that was 2, 3, 4, is the only way that could be a 9. Okay, I don't know enough about that. Oh, that can't be a 6, since I got the 6 up here. So there is a 6 in one of those 2 cells. There is a 3 in one of those 2. That's not really doing anything. Okay. What comes next? What clue am I not paying enough attention to? Feels like the 21 and the 26 matter. The 9 maybe? Okay, if it's not a 2, 3, 4 3-cell sandwich, which could occur there or there, then it's a 2-cell sandwich, and its 1 is down here. So those 2 could add up to 9, and that would be a 9. That would be a 5, and that's impossible because of the 2, 4, 5 thing. So we can't have a 9 in this cell, so that can go green. So there is a 9 in one of these 2 cells in the 19 cage. And now, if it's there, what would these 2 be? They couldn't have a 1, 5 or 7 in, so they would be a 3, 6 pair. Oh, that can't be a 7, I've just spotted. For some reason couldn't read the numbers at the top all the way down to the bottom. So I'm still trying to think about, if this was a 2-cell sandwich, the only way is it those 2 cells. And they would be 3, 6. That's just necessary. And that would be a 1. Well, that couldn't be 3, 1, 11, 10. So it would be 6, 1, 7. 1, 6, 3, 9. And those 2 would add up to 10. It does look possible. Now, the alternative is a 3-cell sandwich, but that could be here. 2, 3, 4 there with a... Well, that would be a 4, in fact, because of the 2, 3 there. Oh, I just don't think I've got enough info. Maybe let's have a look at this 21 again. If that's a 9... then we've got possibly 8, 7, 6 here. And a 1 there, that seems to work fine. Oh, there must be a 6 in one of these 3 cells by Sudoku. There must be a 3 in one of these 2. I hadn't noticed that before. Oh, well, that's quite interesting. If the 3 is here, that forces the 9 to here. This becomes a 7. Oh, this can't happen because the 3, 6 was going to be what the sandwich had to be if it was a 2-cell sandwich. Yes, you can't have a 3 outie in this column because I think we've worked out that if there's a 2-cell sandwich, it's 3, 6, and specifically there. If there's a 3-cell sandwich in one of those positions, it's 2, 3, 4, and that uses a 3. So we can't put the 3 here because that will become an outie, whereas the 3 needs to be it needs to be in the sandwich. So that's not 3. This is 3. That's green. This is the only place left for red in box 3, so that's the 9. This is now not a 9 and is green. Now again, yes, now this is not a possible, this C is 9 and 1, so that's green. So now this is the sandwich, 2, 3, 4. We can put the red 1 in there. These are all green. Now there's a 0 clue in this row, so that is a crust. These are green. This becomes a 1. This sees both a 1 in its box and a 9 in its row, and anyway we need at least 3. Now what are the outies here? If the innies in the sandwich add up to 21, the crusts add up to 10, that's 31. The outies add up to 14, and there's 7 there. So this is either a single 7 in green or a 2, 5 in green. I don't think I know the answer. I do know the answer to this. 4 cells adding up to 26 is 8, 7, 6, 5. So, and this is 2, 3, or 4, therefore, but 2 and 4 have been used in the box. So that's a 3, and actually that's going to get quite a bit of work done. That looks over here at this. I don't know what's going on there. Let's try and get rid of those colours. There we go. So 2 there, 3 there. In the cage, that makes this a 7. Actually, that doesn't sort out the next digit, which I thought it was going to. That 2, though, looks across here, so that's a 5. This is a 3. That does sort out most of the bottom row. We get a 5 in box 9 there. This is a 4, 8 pair. That's not a 5 now, nor's that. That hasn't resolved whether this is a 2, 5 pair or a single 7. This is a 5, 2 pair up here. They can go in. Oh, 2, 3, 4 triple there sorts out 8 and 4. This is a 6, 8, 9 group. That could still be red. 1, that can't be a 5 in the box. 2, 3, 5, 1, 4, 6. Oh, okay, that sort of ran out of steam. Right, this is green because it sees both the red 9 and the red 1. 1 in the column, 1 in the box. So this has to be red in box 7. So that's the 9. That's part of the crusts of this 14 sum. Now that could be as many as 4 cells long if they were 2, 3, 4, 5, or as few. No, it can't be just 2 because they would add up to 14, and that would have to be a 1, which it can't be for the cage. So it's at least 3, and it could be 4. That one though is Well, actually, both of these cells see a 9 and a 1, so they're both green. Now, there's a 1 in the 11 cage, but that's hardly a surprise. That is 6 or 7 by Sudoku. Now, there's a 1 in one of these two cells. Yes, but we've worked that out before. This is either a 2-5 pair or a single 7, and 1 comes after it. So, do I have to work on something else? Maybe this 15 cage. That is 2, 4, or 7 by elimination. Oh, and that's in the 14 sum. So if that was, I don't know which is more likely to be right. Ah, actually, that's green because it sees a 9 and a 1. I'm looking at this 6 sum and wondering if I know a bit more about that than I realise. Oh, hang on. Right, this group of cells, I know what they are because I've got 1, 2, 3, 5 in the box and 9, 4 in the row. So it's a naked triple, a ménage à trois, if you like. That is a 6, 7, 8 group, and that therefore is the whole sandwich, and this is the 1, which was what I suspected was going to happen. I just hadn't found a way of proving it. So this pair do add up to 5. They are 2 and 5. That's a 7, that's a 6. This is not a 7. In fact, this is now a 4-cell sandwich here, so we know that it's 2, 3, 4, 5. This must be a 7 in the column. That's an 8 in the box. These have become a 4, 9 pair. Let's take the corner mark out there. Now, what about this 19? Oh, three equally possible ways of filling that. What about this 11? Oh, many fewer. No, not many fewer, exactly the same number. Sorry. That is 8, 7, or 6. So this is 2, 3, or 4. Bother. That didn't get resolved at all. What about this 15 cage? This is 2, 4, 6, or 8. Look, all the odd numbers have been used in this row. So that's even, and that's even. But we need an odd sum, so that has to be odd. Isn't that odd when you get to use parity very randomly in a puzzle? That is also 2 or 4. Now, do we know whether it's a 3 or a 5? I don't think this can be low, can it? If that was 2 or 4, those two would add up to 6. That's nonsense. If it was 6, that's 4, that's 5. But if it was 8, they have to add up to 7, and there's 2 ways of doing that. But anyway, we've got a 6, 8 pair in this box, 1, 7 pair there. Haven't thought about this 24 cage plus shape at all. Oh, look, this 14 cage is finished. Has been for ages, and I just haven't noticed. My apologies. This now can't be 6. Been looking at all those other perimeter cages and just not focusing on it. I was going to say I could suddenly do something with the Fistemafel ring because I've proved all the 4 corner boxes, but actually I know all the constituents of that ring as well, so it doesn't change anything at all in this puzzle. That is 2 or 7 just by Sudoku. Now, come on. These sort of push it. Oh, that looks like it can't be. It's not a 5 because of that sum, and since we got that 3, it has become a 2. So this is a 4. Probably doesn't push us forward in columns 4 or 5 at all. Now, it's this 6 sum maybe. Right. Okay, here's a knowledge bomb for this row. This 6 sandwich is not a 1-cell sandwich because The only place where you could put two reds surrounding one cell is there, and that can't be a 6. Therefore, it's a 2-cell sandwich containing a 2 and a 4, and that rules out that pair. So this is not the end of the sandwich. That's green. This is now in the sandwich because it's either those two or those two cells, and it's a 2-4 pair. Now, which way does it go? Is that a crust and that a crust, or is it that a crust and that a crust? I don't know. I don't know, but I do know there's a 2-4 pair in those 3 cells, so that's not a 2, that's a 3. So that's not a 2 now, and that means that's not an 8. Now I've got a 2-4 pair in that column, so that is a 3. Crumbs. 7. Oh, and then I suddenly find that that 2 finished off the cage and I didn't notice a moment ago. Never mind. This becomes a 5. These two add up to 10. There's still 2 ways of doing that, but have I narrowed down where the 2-4 sum is? Not completely. No, no, no. So I've taken 8 out of those cells. I can take 5 out of that one. Ah, that 6 and 7 have sorted out a couple of pairs down here, and one of them has hit a cage, and I've finally noticed. 4 there, 2 there. Now, where does the 4 go? That side or that side? Don't know. 2, 7. Let's just do Sudoku instead. That's become a 6. Now I've got a 5, 7 pair. I'm going to put in a 4 and a 1, 9 around it. Oh, good grief, I still don't know how it works. That's not a 6 anymore, nor's that. In fact, they're an 8, 9 pair, so this is a 2, 3 pair. That's a horrible, well, that would be a deadly pattern if it wasn't for the fact that this is in a cage and that isn't. That's going to change that up. Now, actually, let's not forget to colour, because it can sometimes help even in rows and columns which aren't given sandwich clues, weirdly. So one of those is a 4 and one's a 9. Do I know which? No. But I've got these 2, 3, 5 triples in both row and in both column 4 and 5. So these are from 1, 4 and 9. Oh, and this might be very interesting in the plus shape. These 2, 3, 5, 7, 6, 1. These are from 4, 8 and 9. So now maybe I should think about the outies of this plus shape rather than the innies. These have to add up to 21 because I've subtracted 24 from the magic 45. So say that was a 7, then these two would have to add up to 8, and that's not possible for those 2 cells. So that's a 5. So that is how to do it, goodness me. So they add up to 11. These two now have to add up to 10, and that's got to be 8 and 2. And it's suddenly remarkably straightforward when you look at it that way. Now, we can sort out the deadly pattern that wasn't deadly. That's not an 8, so it's a 1, 4, 9 triple. Let's just check the maths of this cage. Yes, they work, so that's fine. This is a 1, 4 pair. Now, this 6, one of those two is a 4, so that's not a 4. So that's now red. That is a definite crust. And it's a 2-cell sandwich, so that's a crust. And this is not a 9. This is in the sandwich. That's a 4. Wow, and there we go. That must be a crust as well, because all of these are green. So that's not a 4. Yes. Okay, so let me just fill in the rest of the greens that I can identify. I think all of those have to be green, and that one. These others are the crusts that must remain. And I can fill in the numbers now. 9, and I mean I can finish off the puzzle, I would have thought. That's obviously a 9. This is a 1, and this crust is a 9. And this becomes an 8. 6 there, 5, 7, 6 and 8, and that is a very clever puzzle. And now, of course, I see the plaid lunchbox. We've got a sort of green and red pattern as on a sort of tartan lunchbox. But yes, why didn't I realize that I was going to be doing that? I think Redundant knows how I work these puzzles better than I do, but it's a very neat combination of killer and sandwich there. I did note that the killer cages were all symmetrical fully at the start. The sandwich clues, interestingly, are almost all symmetrical, except that instead of a column 5 clue, we get a column 6 clue. Otherwise, they would have been symmetrical. But it's a very clever construction, and I hope you had a go at that and had enjoyed the puzzle as much as I did. Good fun there, and an absolute pleasure to bring it to you. I hope to see you again tomorrow. Bye for now.